Hello. In this architecture finger food session, we are going to look into the template method pattern. We also will look at a very famous application of it, as well as its implementation based on the Java programming language. Before we start, let's ask ourselves the following question. If SAP was not there yet and we were to invent its fundamental ideas of deferred customization, then what would be the kind of idea that would give us that breakthrough? Well, absolutely. We could have or would have to think about a system that distinguishes the following two major aspects. The first aspect would be the one of a generic and foundational framework. The other aspect is the one of customizable components that can be tailored to whatever specific needs a concrete company has in the future. There is a relationship between these two aspects of SAP and similar systems. First, the foundational framework pre-implements to quite a huge extent, let's say 80%, pre-implements a solution that would be applied over and over again in all different company contexts. This foundational framework would foresee customization hooks for companies who are going to implement that framework once. Whenever that framework gets purchased and implemented, the remaining 20% customizations still need to be done, obviously. So again, the generic framework underpins any of its implementations, which means that it has all generic aspects of, for example, an end-to-end process already pre-implemented. Let's look at a concrete example. Think of SAP's HR module and one of its core backbone processes like the employee lifecycle process. Let's further assume that this process is going down all the way from hiring a person to laying off that same person again somewhere in the future. To be more concrete, let us assume that SAP's research department detected that the fundamental flow of events throughout an employee's life cycle, in all companies, is to first hire the person, then to use the person, and then finally to fire and forget that respective person. So while there is a general logic on the process level, concrete implementations of all individual process steps are always deferred to an appropriate implementation project. If we say that two companies A and B purchased the same SAP HR module as a COTS, so commercial off-the-shelf package, then both companies would have bought the exact same backbone process, and since this would be part of their system's compile base, the backbone proportions could not be altered by either A or B. The good thing, however, is that SAP made their HR module customizable. Therefore, both A and B could possibly have significantly different implementations of their HR systems by differently implementing respective process steps as indicated here on this slide. So far so good. Now let us assume that we wanted to build such a system, and let us further assume we wanted to use architecture patterns as much as possible to not reinvent design wheels over and over again. So how would we express our problem? Well, we need to be able to finally fix the process logic on the level of our SAP HR core system, i.e. the foundational framework. This is the SAP process contribution. At the same time, we want to be able to defer the implementation of all individual process steps to a later stage, since SAP does not know how, for example, IBM prefers to hire a person in contrast to how HP would implement their hiring step. So let's go and stroll through the pattern catalog that we see here on this slide. You may have already looked at it. Whether we find a pattern that matches our specific needs. Okay, here we go. Surprise. We have one pattern that actually sounds quite promising. Let's give it a quick read. So the template method pattern, the one that is highlighted here on the slide, says that it matches problems that ultimately match up the following problem description, which goes: define the skeleton of an algorithm in an operation, deferring some steps to subclasses. Template method lets subclasses redefine certain steps of an algorithm without changing the algorithm's structure. Well, to me this sounds like, well, quite perfectly fitting our actual problem. Now that we have found a promising candidate pattern, let's give it a closer look and a more detailed read. In the template method of the template method design pattern, one or more algorithm steps can be overridden by subclasses to allow differing behaviors while ensuring that the overarching algorithm is still followed. In object-oriented programming, but not just there, first, a class is created that provides the basic steps of an algorithm design. On this slide over here, that class is called base class. These steps are implemented using abstract methods. Later on, subclasses change the abstract methods to implement real actions. Thus, the general algorithm is saved in one place, but the concrete steps may be changed by their respective subclasses. In the general template method pattern description, here we have two subclasses, child class A and B, overriding base classes hook methods 1 and 2. The template method algorithm, as shown in this example, fixes the sequence of the two hook methods being called hook method 1 and hook method 2 in that sequence. Now let us go back and see how we would apply this pattern in the SAP HR module context. Well, first on this slide I flipped the generic framework to the top and the customized components illustration I moved to the bottom of the slide. What is more interesting though is the UML model to the right. There you see a class which I called SAP HR, which corresponds to base class in the template method pattern on the previous slide. 4 methods in this class are kept abstract, which means that the framework developer, so the SAP developer in this context, so that the framework developer explicitly defers implementation of these classes to respective child classes once SAP HR gets adopted within a concrete company's context. In the example here, we have added IBM's and HP's implementation. The method lifecycle manage in the class SAP HR obviously corresponds to the method that was called template method in the generic template method pattern description, yet again on the previous slide. Furthermore, we see how SAP has decided to generically implement this method based on their experience and respective research. So if a person gets hired, that person will be used by the company, then fired, and finally will be forgotten about. Okay, now let's go and implement this in Java. So the first thing I want to do is to actually create a class for the person object over here. I have already brought up Eclipse in the background, and the first thing we do is we create that class. So we go new class, then we enter person, and we will just add 2 more attributes to that person. First name and last name, that should suffice. So string first name, and we set it to null, and then we have string last name, equally set it to null. A constructor comes in handy when we want to actually instantiate such an object, so we give it the same name as the class name itself, obviously, and we add 2 string parameters that would be used in order to actually initialize that object's attributes. So first name and then string last name. Now we copy the data over from the parameter to the actual object attribute, and we do this for both attributes. Let's override the toString method. And just plot out first name and last name accordingly. Well, simple schema. I think this will do it. Alright. I think this is it. We don't have to do anything more to this class. So now let's look at the next class to be implemented. Okay, the next class that we will implement is SAP HR this class over here, so the foundational framework, the compile base that SAP as a company would actually ship. Go yet again over to our Eclipse editor, and we add an appropriate class to our project. So let's give it a name, SAP HR, and then let's add the methods that we have in the UML diagram. I'm just quickly toggling back over to PowerPoint. So there is a class which is called hire and would expect a parameter of type person and is qualified as abstract, and the same is true for all the other basic and primitive methods over here, and we are going to create them first. So hire, use, fire, and forget. All right, let's start with hire. Public Boolean, because this is expected to be called within the context of a conditional branching statement. Public abstract Boolean, hire person, and that's it. Public abstract void use person, public abstract void fire person, and then finally public abstract void forget person. So let's quickly check what this one says. Obviously the class itself needs to be abstract as well. Alright, now so far so good. There is one method that we haven't implemented yet, and there we can actually provide an implementation, a fully fledged implementation already on the level of this abstract class. So it's, if you want, a semi-abstract class. It's not a fully fledged 100% abstract class, because this method we will already implement on that level. So the name of the method is lifecycle manage. So let's just stick to the name. Public void lifecycle manage person P, and the implementation goes if hire P, then use P, fire P, and finally forget P. And with this we already have implemented this class. So quickly again, lifecycle manage person, this is the template method implementation, and the other four methods, they remain abstract, so there is no implementation that this class already offers. Quite the contrary, it even mandates anyone who's going to inherit SAP HR and further implement it out to necessarily provide an implementation for these four methods. So that is really something that the framework designer and developer already put into the SAP HR class as a mandatory step to be done when it gets adopted. Okay, so the last class that is now still missing, or one of the two, is this one, SAP HR IBM. So this is IBM's implementation of the SAP HR standard module. Now go back to Eclipse and create this class. Let's call it SAP HR IBM. And we need to now inherit from SAP HR Java. So I put it here. Their father class, or the superclass, is SAP HR. And inherited abstract methods, there should already be a method stub that is being created by the editor system. I'm getting rid of all the comments, that's not that important. So you see now, if we provide an implementation for each of these methods, then well, we have our implementation, or IBM has their implementation of the SAP HR module finalized. Now quickly go through it. Let's say person with a first name of, or let's go like that. So if a person matches the following, starts with, well, let's hire myself there, then the whole thing would go fine. Everything else would every other hire would be not accepted by the IBM company in our implementation. Let's just go with this. Then IBM is using a person. Now, how does IBM actually use a person? I'm putting a console printout right into here. So let's go with system print line. Sorry. System out print line, and then we put the person there, but maybe something in beforehand, like for example, please get this work done, dear. And now we add the person. We can do similar things in the fire method implementation. Please leave this company, dear, and still we keep the name of the person there. And last but not least, the final method, which was to forget about the employee who was once with the company, who is that person, by the way, something like this. Now let's save it, and with this we have already implemented a first SAP implementation at IBM based on the generic method behavior, which was captured here in the template method. Also for IBM, that process holds true. So if the hiring step is successfully be performed for a given person, then these steps would follow. The person would be used, fired, and forgotten. Just the difference between like IBM and HP is how IBM would actually hire people, what criteria they would apply, and that people would have to match in order to be actually recruited by IBM, as well as how IBM uses people, how they fire people, and finally how they forget about people. Okay, so with this class we are very close to an end. There is just one class missing, and this is going to be the next step. As the final step, we just need to pull the different bits and pieces that we have created so far together. I'm creating another class for that purpose. I will call the class client because it actually pulls everything together and is finally the class that we will use in order to run that program. Let's add a main method to it, so that's the entry point for the operating system. So when we want to run that Java program, then this is the right place to start. Okay, let's get rid of the comments again. Don't need them. All right, so now let's quickly have a look. The first thing we want to do is we want to create a person. So let's go. There's two persons. Let's say P1, and we create that person with name Max, I don't know, Schmeling. There's another person, and so to give IBM the opportunity to really find somebody who they are okay to hire, I'm creating that other person along their criteria, which was Ingo Arnold. Then we need the framework class SAP HR and a respective object or a local reference variable. Let's say HR system. Now the actual implementation for that reference variable over here of type SAP HR will be pointing at this concrete implementation, so IBM's implementation. Therefore we need to create a new object on the heap based on the following class, SAP HR IBM. And then it is up to us to have somebody hired and enrolled. So we tried with two people. First is HR system lifecycle manage P1, and then we do the same for the other person, P2. what we would expect, and maybe we can quickly alter the process here. Let's add in an else branch over here so that we see if the recruitment was not successful. Just plot something out into the console window. Let's say not successfully recruited, and then we add the name of the person. Okay, now we would expect in these two lines that P1, due to the fact that this person doesn't match the recruitment criteria of IBM, which is matches up with this name basically, we would expect that statement to be plotted out down here. And then for the second person, we would expect these statements be plotted one after the other. Well, that's all theory. Let's now really give it a try and run the program. So we go run as application, and here we go. You see it down here in the console window. For P1, so this line resulted in this output, so not successfully recruited Max Schmeling, and this line ultimately resulted in the following output. So please get this work done after you were hired by IBM, dear Ingo Arnold. Please leave this company, and then who is Ingo Arnold? So as you can see, we have now implemented that whole pattern, or an application of that pattern. Let me quickly toggle back to the screen show. So we have created those classes. We have fixed and finalized the template method level algorithm on the level of SAP HR. This was just adopted by the inheriting implementations. In this case, we just implemented it for IBM. We could have done the same thing for HP, obviously. We were very explicit about the fact that hire, use, fire, and forget are abstract, so there is no implementation existing on this upper level. So we have deferred their implementation to the respective inheriting class, which is SAP HR IBM. We have pulled it all together in Java, and we have finally executed the program with this output.